The new fault system modeling feature allows you to quickly create framework models of faults and their systems. For example, on the map, we can see several fault traces at the surface, and their dip and strike elements are known. We can draw these lines in plan view, then project them onto the specified surface to assign each point its absolute z coordinate. With the fault system modeling task, you can automatically load a list of faults and define for each its azimuth and dip values. You can also limit the fault framework generation by a surface from above, such as the topography or any other constraint. In this example, no top limit is defined, so the modeling will be performed within the general boundaries. The sequence in the fault list table is important. For every fault, you can set relationships with neighboring faults and specify their interaction type. You can also automatically create solid blocks between fault systems. These solids can later be used as boundaries for modeling other geological bodies inside each block. If relationships are not defined, the entire volume within the boundaries will, by default, be divided into two blocks by the first fault in your list. In this case, Fault 1. To the north of Fault 1, we see a blue solid. To the south, a brown one. Now let's define a connection between two submeridional faults, Fault 2, green, and Fault 1, yellow. For example, we'll select the joining type in the interaction column, meaning that Fault 2 joins Fault 1 from the south. As a result, the brown solid located south of Fault 1 will be divided into two blocks, to the east and west of Fault 2. Between Fault 1 and Fault 2, we can also see a sublatitudinal white fault, Fault 4. We'll specify that it joins Fault 1 from the south and Fault 2 from the west. As a result, we obtain 5 solids that represent the relationships within the fault system. The initial block lies north of Fault 1. Another one is located south of Fault 4. 2 blocks appear to the southeast of Fault 2, and 1 triangular block is enclosed within the system formed by Fault 1, Fault 2, and Fault 4. Model your deposit structure with the new K-Mine fault system modeling feature. Save time and enhance the accuracy of your geological interpretation.